in sets. We've got 21 through 24. Y'all are okay with those about not using substitution and why you can't use substitution.
Well, I'll tell you exactly how you get 25.
Okay, so you don't get it on that set? You are. Well, I'm just looking at the set in your book, 21 through 24. Ooh, I chipped my tooth last night. I know. I bit down on the fork.
Oh, I did that the other day. That sucked.
Yeah. So now there's a little hole in my tooth right there. All right. Let me just, for the sake of making sure that I cover everything for someone who maybe doesn't want to ask, because everybody's saying, hey, it's good, I got it. Why? Okay, so this is 21. Okay, but 2 wouldn't give me a negative under the square root. Yep. Oh, well, there you go. Sorry. Okay, so you can't have a negative under the radical, right? There's no graph over there, so that's why you can't use substitution. Why could I not use substitution here?
I said you must check those out.
That's right. So if you think about what a square root graph looks like, right? This is saying I start at 2 and I'm going off in this direction. The limit as x approaches 2 here. Remember, for the limit to exist, the limit from the left must equal the limit from the right. Where's Ren?
He's probably like, I don't know.
And because they don't equal, it doesn't have a limit there. It's got a right-hand limit, it doesn't have a left-hand limit. I read that problem wrong whenever I was helping someone yesterday. All right. Why you can't use substitution, okay? So 21, I can't have a negative under the radical. 23, I can't. 0 in the denominator, right. All right, let's look at the next section.
Wow.
23's absolute value of x over x. The limit is x goes to 0.
You don't talk about math.
If we get it, I just need to find it to the right and left. And instead, I saw there was x over x, so I made it negative and I made it positive.
But look, did it ask you to evaluate? Oh, find the limit if it exists.
So then I found that one of the limits would be one of the limits.
Do what? Well, open the middle drawer and it unlocks the side drawer. It's weird. All right, for 23. All right, guys, for 23, I would probably graph this one and look at it on my calculator. So if you don't know how to do the absolute value. If you go in y equals and then you hit math, yay! Go over to NUM for num all day. Choose that first one, ABS, and then do your X and close your parentheses. Y equals math. Scroll over to the right, NUM. And abs. It gives you the pi over 2 as your X.
Okay, I was wondering if it makes sense to graph like this.
I still haven't downloaded my calculator. I apologize. Oh, here it is. Ha! Absolute value of x divided by x. All right, so you should get a graph that looks like this, right? And it's asking me for the limit as x approaches 0. What do you think? The limit as x approaches 0 of this graph. It doesn't exist. It took us. I'm sorry. I couldn't hear you. Couldn't hear you over the din. So make it positive. It flips all the negatives to positive. Do zoom 6, so you got a standard window. Hit math over to num. Math, and then you go over to NUM, and it's the very first one. All right. Let's go to the 25 through 33 section. All right. Is everybody with me? Y'all are so stressed. Y'all are like, squirrel. Okay. All right. 25 through 33. Determine the limit graphically. Confirm algebraically. Ooh. So these are ones that require us to do a little manipulation with them. Okay. Okay, so here's what you know. So you always, the first thing you want to try is substitution, right? Clearly substitution is not going to work here. Why? You can't have a zero in the denominator. If I try to apply those properties, what happens? I mean, I could do divided by, but I'm still dividing by 0. Those properties aren't helping me a whole lot here. Do we agree? Here's Coach Carson. Okay, I got to algebra that thing. I'm going to try to write it a different way, a little bit different than what it is now. What do you notice? We're still going over homework, Coach Carson. I'm sorry. I need to factor it, right? Does everybody see? All right, so do you agree? Do you agree that is the same thing? What's it called? What's that called? A difference of 2 squares. It is. Okay, that's all right. That's all right. But now what happens to that fraction? Agree or disagree?
And you just plug in 1 over 2. How many bugs do you? I really don't.
What do I do now? Now I can substitute. If there's a reason I can't, I got a negative under a radical, I got a 0 in the bottom, any of that happens, try the properties. Or try to manipulate some way. I got you. Okay, rewind back to pre-cal for a minute. What happens on the graph here? There's a hole. Look at you, man. There's a hole there, right? If it cancels out in the top and the bottom, there's a hole. At 1. A hole in the graph at +1. That's exactly right. That's exactly right. Because you cannot have a 0 in the denominator. It's not a full-out asymptote. No, it doesn't have to do with the limit. It's got to do with it because this canceled out. Because if you plug the 1 into the original equation, it's going to cause a 0 in the bottom. It's going to cause an undefined point. But I can simplify it down and rewrite it this way, and it's the same function. The only difference is I have to leave out that value that was causing trouble initially. So it's just, I mean, it's literally like a hole in the graph. What was the word? Like whatever the graph is, and then there's a hole. It's just one undefined point. So what does the graph of this look like? So let's graph it and see. So graph it on your calculator. Let's do it together.
So I had trouble in the beginning last night, not getting the graph, but figuring out where the hole was.
The holes happen every time something cancels like that.
I know, but like I would pull the table and it would say like
Error.
Yeah, is that?
It could be a hole, but it could also be an asymptote. So you have to, that's where you got to take that pre-cal knowledge and know if it cancels, it's a hole. If the bottom equals 0, it's an asymptote. Like it doesn't cancel. So like the 1, so positive 1 is a hole, but negative 1 is an asymptote. Hold on, I'll pull the thing.
You had to learn to graph like
By hand.
But I don't even know what that's called. Whenever it was like this condition.
If you're looking at this, try to figure it out. How would you know?
Okay, so if you're looking at this, you would never realize there was a hole at 1, right? You see that? Because at 1, right, it looks like there's a piece of graph there, but there's not. I know there's not because I know that bottom, if I plug 1 in, it would give me 0 on the bottom. Are y'all following me on that? Right. The first thing you always do is set that denominator equal to 0 and find those points. Find what x is undefined. It's undefined at 1 and negative 1. And then I decide what kind of undefined is it. Is it an asymptote or is it a hole? It's a hole if it cancels. It's an asymptote if it doesn't. Yeah, Lizzie. Look. Did you see it? If you go into your table on your calculator, you should have an error at 1. So your calculator graphs asymptotes. There's an asymptote at negative 1. Some of them just do. All right. Yes or no? That's algebraically and graphically.
Yeah, we got it. Let's move to 27.
Okay. All right. Let's do. Let's do one with it. I don't want to do them all for you because a lot of you need to go back and do them and you need to practice with it. I was going to suggest, you really want 29? Okay, y'all don't have a problem with 31 and 33 with the trig function in there? If you remember your little friend from yesterday, your sine x over x, you should be okay there. Okay? So make it sine squared x is the same thing as sine times sine. So if you have sine squared x over x, you could rewrite that as sine x over x times sine x. This you know is the one, right? That's the one you got highlighted in your notes from yesterday. Then you get the sine of 2. Sure.
Okay, how do you plug
That's
sine
29.
squared x
That's
into your calculator?
so you have to do sine x squared. But you know sine 0. That's on your unit circle. No. 0. Man said that was a prank. Yes, because 1 times 0. Okay, Dylan, what'd you say? 29? Yes. All right, 29. The limit is x goes to 0. I've got 2 plus x cubed minus 8 over x. I can't just sub in, right? I've got 0 in the denominator. Okay, so did you, oh, this cube is supposed to be. So I'm going to say the only thing that I could do here is some algebraic manipulation. Do you agree? What could you do? What do you do? Okay, but you can't distribute it because why? I'm adding. So this is foil on crack, right? 3 foils. I thought your middle name was Delta. Oh, unit circle. That's right. That's right. All right, what's this look like foiled out? 4 plus, which is 4x, times 2 plus x again. I told you. No, don't ever bounce it. When you're multiplying, never do more than 2 at a time. All right, let's multiply everything by 2. I'm going to take this step by step because this is the, and now give everybody an x. I'm going to go out on a limb and say I think that that x is going to cancel out whenever I get this x cubed. So I have x cubed, 6x squared, 12x, plus 8 minus 8 over x. 8's are gone. Look what else happened. They do cancel. Now all of these have an x and there's an x here. So I took every 2 to everybody, that's these 3, and then I took x to everybody, and that's this. You can do that. Yes. Because essentially what you're doing is times x squared plus 6x plus 12, and then that's gone. Right, right. Then it's a substitution situation. Are you feeling a little bit better about it as we go through some of these? Katie? Katie, you're good. All right, that's the next section. Everybody's okay, yes? I'm not moving until y'all all tell me yes. Don't tell a story. Okay. Okay. Psych, we got it. All right, 35 and 36 say to use a graph that shows that the limit does not exist. I think before I give you your homework from now on, I'm going to do one from each section. Model those. We just ran out of time yesterday. Okay. All right, so 35, you had to show the graph, show it didn't exist, so the limit was different left to right. Okay, that's an easy solution, yes? Okay. It said, somebody said what? If you graph this on your calculator, you will see at 1, the limit's different as you approach from the left and from the right. So the limit does not exist. Graph it and look at it. When you graph it, you'll see. Kind of like that one we did that looked like this. At this point, the limit is different from the left than it is from the right. Yes. For which one? Yeah, and it tells you that. It says use a graph to show that the limit does not exist. Okay. Yeah, that's fine. Or you can just say the limit's not the same. You don't even have to put it on your paper. It could be an asymptote. It could be a whole. Or, yeah. It could be an asymptote with them going off in different directions. It could be something like this, where they're coming in at different. Okay. Yeah. But if it's not the same from both sides, it does not exist. Yes. It's okay. It's okay, yes.
How do we?
Well, once the 8's canceled, everybody had an X to give. I've got 3 X's, 2 X's, and 1. Whenever everybody had an X to give, yes. Yeah, you can factor the X out as a GCF and then cancel it. So that one, you're going to factor the bottom. You've got sine X over 2X squared minus X. If you take an X out of the bottom there, right? This is your little friend, sine X over X, right? And then you're going to 0, so you can plug in a 0 there. 0 minus 1 is negative 1. That's that one. Remember I told you highlighted in your note? Yep. The limit as x goes to 0 of sine x over x always equals 1. If you ever see that you can take that out, do it. Oh, sorry.
So is that one equals negative? That one equals 1 and then that one's 0?
It'd be on the inside. It'd be
2 is on the x and the inside. 2x squared minus 1.
Oh, okay. Sorry. Still 0. It's still negative 1 on the bottom, right? Yeah. So if I put the 0 in there, I get 1 over 0 minus 1, which is negative 1.
So what would you do with the information that sine x is 1? You put that on the top. Sine x over x is 1.
Yeah. It's 1 time, right, because, all right, so sine x for x. Girls. Here. Same thing, right? So this is 1. Because I'm using that property to break apart those limits. Okay. All right, as he writes that down, let's move on to the next. Yeah. Oh, yeah. Sorry. I keep putting it in there. I'm sorry. All right. The next one asks me to determine the limit, and it's one-sided this time. There are only 2 ways we have talked about. I'm talking about 41 in the next section. 2 ways. Okay, 2 ways we've talked about extensively. What are the 2 ways I can use?
Substitute or graph.
So, okay, but substitution doesn't work.
Well, yeah, not this.
So graph or. Okay, but I can't really split up absolute value. What did you do on the very first day? And y'all got so aggravated because it was so tedious.
Oh, the chart?
The chart,
Yeah.
okay, right? You could go in and you could come, if I'm approaching 0 from the right, okay? And so that's probably the easiest way to do is to graph it and look at it. But just so you know, there's another way. Well, from the right, so be positive. Okay, X. Meg, they only act like that when they're not right very often, and they get really excited because they get right. You can't just let somebody be right. You're either right or you're not. Oh my goodness. All right, one-sided limit from the right. So I'm coming in from the positive side, going towards 0. What is it approaching? 1. All of these, I hope, as you were talking about them, are easier than you thought. Okay. Yes. Yes. That's always what you're looking for. You're always looking for the y value. As x approaches something, what is y? 1. What's the limit as x approaches 0 from the left? -1. That's right, -1. What'd you do? You plugged in values? You did it by hand? Oh, by hand. But it's not hard because absolute value, it's really just 1 every time, right? It goes over itself. Aaliyah. Yes, you do. What does absolute value do to a number? It doesn't flip the sign, it makes it always positive. That's all it does. All right. Sorry, I didn't mean to bring you out. All right, that's the next section. Yes. On to. Yes.
Wait, hold on. Can you do 43?
Okay. I wanted to ask you about the section, the 43 through 50. Those are typical questions. In fact, we saw an FRQ with a graph like this last year. Yeah.
Unrelated to the homework. Anything divided by itself is 1, right?
Except 0. Except 0. We had this discussion at my house night before last. You cannot divide by 0. It does. It doesn't. Anything except 0. Yeah. Yes. All right. Let's look at 43.
Are you gonna do all of them?
Yes. In fact, let me pull up the file so we can look at the graph. That's okay. Quick to talk through. All right, 43.
I mean, they're all asking the same thing.
They are. If you can do one, you can do all the rest. All right, so let's look. The first one says the limit as x approaches 1 from the right, and it's telling you to tell which ones are false. Is that what it is? True or false? All right, 43.
Okay, A is correct. A is correct.
All right, the limit as x approaches -1 from the right is at 1. So as I come in from the right, -1, just kidding, is it 1?
Yes.
Yes. True.
Does it matter if it's one close or inclusive? Like,
No, it does not. That does not have it. Remember, that has to do with the function value at that point, but not the limit.
oh, that makes a lot of sense.
Okay, because you're going to get to that when we get to 0, right?
Yeah.
All right. How about 0 from the left? Is it 0? Okay, so as I approach from the left-hand side, from the negative side, and I get closer and closer to 0, but it's approaching 0, right?
Yeah.
True.
So what I'm asking is,
The whole doesn't matter. The whole just defines it or not defines it at that point.
That's what
what I'm asking is like B, it makes sense because it's approaching 0, but like for A, it literally hits 1. So.
But it can be 1.
I know. So like, how's that a limit? It doesn't just approach it. It goes to it. It goes to 1.
Well, it approaches it and it hits it. If it hits it, it still approaches it.
Right. So
That's when your substitution works.
Yeah. Okay.
That's when substitution works.
Correct.
If that makes more sense.
Yeah, that does.
Okay. 0 from the left. Did we just do that one?
That one's gonna be false.
That one's false. If this is true, this one's got to be false, right?
Yeah.
0 from the left, we said is 0. Even though that point is filled in right there, the function's defined. The function value at 0 is 1, but the limit coming to 0 is not.
Oh, so that would be like the value at x equals 1 is 1, but the limit is. No, sorry. The value is 0.
The value at 0 is 1.
I'm talking about for the other one, the one on the right.
For what?
Like for 1. So like those 2 points on the right.
Here. Yes. Okay.
So your value would be 0, and your limit would be 1. Right there.
Your limit does not exist there. What's the left-hand limit versus the right-hand limit?
Oh.
They're not the same. We'll get to that one. We'll get to that one. Let's go to the next.
So you.
All right, so C is false because 0 from the left. So if I approach from the negative side and I come closer and closer to 0, my graph is getting closer and closer to what? 0. It doesn't matter that it's jumped up to 1 right there. It's not approaching 1. It might be 1 there, but it doesn't approach 1. We're not approaching.
Wait, I thought they were, as they move towards 0, it was going to 0.
So you're exactly right. And that brings us to the point. If the left-hand limit and the right-hand limit are the same, the limit exists, right? So the limit of 0 as x approaches 0 in general is still 0. It exists. It's the same. But f of 0 is 1. Those don't have to be the same.
Does that mean you have two levels?
Huh?
Like two.
Two one-sided limits, yes.
Well,
You can't have two.
we just do the.
All right. D. Is the limit the same as you approach 0 from the left and from the right? If you come in from both sides, are you going towards the same point?
Yeah.
So that's true. That's true. So does the limit as I go to 0 exist?
Yes, true.
Yes, because D is true, that makes E true. Does that make sense? If the limits from both sides are the same, then the limit exists. Okay?
The middle name.
At 1, look at 1. It's approaching 1, it's approaching 0. So the limit does not exist. So one side is limited. Well, yes.
So anytime there's
It does not exist. Those jump discontinuities. That's what we're looking for. Jump discontinuities do not have limits. They have one-sided limits, not the whole. I love that. Y'all have any worries this morning? Okay. I'm not.
of course, I'm getting
You're not
another
counting.
show.
I know. F is true because we just talked about that. The limit's the same for the left and the right. Okay. Right. If F is true, G can't be true. It can't have two different limits, right?
But if it asks for the value, then.
Correct. F of 0 is 1. Y'all see that, right? This is false, but F of 0 is 1.
Yeah.
Right. Right.
The limit is G is false.
All right. What are we on?
We're on H.
H.
The one that I need.
The limit as x approaches 1 is 1. True or false?
I know the answer is false.
The limit as x goes to 1
No,
is
it's undifferent.
is
It
one.
doesn't, wait.
How does that make sense?
Because
It's
it's
zero. No,
No,
that's
it's
zero. False.
No, it doesn't exist.
Yes.
Why does it not exist?
Because they don't,
Oh,
they're not the
that's
same.
why, because there's no limit there. Oh.
They're not the same.
I was like, that makes sense.
What's the limit as x approaches 1 from the left?
It's not one.
Yes. Look, from the left.
The left is one.
From the left,
Oh,
if
but
I
this was
approach
asking for
1,
both sides.
it's 1. Exactly right. Now, what's the limit as x approaches it from the right? 0. Are those two the same?
No.
If they're not the same, it does not exist. Because F is true. All right, so true or false for H? False.
They're all one.
It jumps up, so it's.
I see really wrong.
All right, Van says I seems to be true. As x approaches 1,
X.
it's 0.
No, one.
It's false because
There's no limit.
there is no limit there.
I was thinking.
I need it for the right size.
So H and I are the same concept. There's no limit there because the one-sided limits don't match. How about J?
J,
No,
it'd be 0, yeah, but that'd be false.
I is false because this is, it's not a one-sided limit. So if it's not a one-sided limit, both sides have to match. And as I come to one from this way and I come to one from this way, then no.
All right, can you do J7?
What is what? J? No, as you approach 2 from the left. What is the limit as you approach 2 from the left?
No, 2 from the left.
It's not on the graph. She's right. It's not on the graph. It doesn't exist either.
Why wouldn't it be 0?
Because f of 2 is 0, but there's no graph. I can't approach it if there's no
Oh, yeah,
graph.
that makes sense. Yeah, that makes sense.
Oh no, but from the left, it does. From the left, it approaches what? 0. I'm looking at it. It doesn't have one from the right because there's no graph over here. I'm sorry, I was looking at it backwards from the rest of it.
The answer's still false.
The answer is still false. Yes. Sorry, we didn't have any.
Hey, nope. This is great.
We're just answering homework questions.
Great.
Well, thank you.
Always great.
Thank you.
You want to come do something?
No, this is Greek, man. There you go. I'm not sitting there and get some of it, but I'd have to go back to like step 1. Step negative.
But aren't they doing good? They came in so confused, and you hear them all there all.
All the dialogue.
Thank you. Come back anytime.
Right? Yes, sir. Somebody y'all at Fox News.
They do. They're very supporting. So, oh, y'all do not act any different when he came in than what. It's late start.
yeah, I got my call back. That's so fun. But there was ants in my car. It's infested.
When?
Yeah.
I've had that happen before.
It's so annoying.
It's hard to get them out. It's hard to get them out. All right. That should set you up. That should set you up all the way through 50. You should be able to do all the way through 50 knowing all those limit properties and rules. Y'all are so mean to each other. All right, how about 51 through 54? Match the function with the table. That should be easy. You just put that on your calculator. Right now. Okay.
Yeah. I was gonna say, because I don't
All right. 55. You're good, or you need me to do it? Okay. 55 is easy. 57.
57. This is where it starts.
That's where it starts getting.
Yes, yes. Hold on, 55. The limit as x approaches 4 of g of x. You see why I said if you spent hours on your homework, there was a breakdown somewhere? Because a lot of them are.
I told you I had to get up to this last one.
Yeah, this one should be super duper quick. So it tells you to assume that the limit as x approaches 4 of f of x is 0, and that the limit as x approaches 4 of g of x. This is just seeing if you know your properties. That's all this is doing. So I will split this up. Somebody asked about 55. Here, right? I've got the value. This was defined for me in the beginning. Yeah, the limit of a constant is the constant itself. And all the rest are going to follow that same, you're just using those properties, that's all. All right, 57.
Yeah, I don't. Swear to get lost.
I'm probably going to have you fix your homework tonight and just add a few more on there. And
Yes,
that's it.
everything up until this point I was good on, pretty much, and then this is where, up until 57. Okay, from there.
That stinks. I care, Meg. Was it good? All right, 57. Y'all are.
That means y'all can't have students in the student section, but we can have a.
Yeah.
Okay, look, let's make it cool. Please email me.
I'm going to graph this by hand because I'm extra. 2, if I plug 2 in, 3 minus 2 is 1. So my starting point is 2. Do y'all remember how to graph piecewise? Start with the bound. Start with the domain restriction here. Plug it in. And then plug in that fits that inequality. So a number less than 2, like 1. So when I teach piecewise, I teach it to, it's essentially what, yes, 2 children. Essentially what it is that's the whole line with a negative slope, but you cut it off at 2 and you only include the piece less than, yeah. Yeah, you could. You can graph the whole line and erase. That's a method whenever I teach it. I do show people that. It's messy, but you can do it.
What's the 3?
You plug this value in to this one.
So if you plug 1 into there, so 2.
Mm-hmm. How'd I get what? So if you plug 2 in for x, 3 minus 2 is 1. It's an open circle. Okay. And then I picked an x that was smaller than 2, so I picked 1. It's an open circle because there's no line under the inequality sign. That's exactly right.
Wait, oh, so you have to do the number itself, so you have to do 2 and 1? Why do you have to do 2 though?
2 is the bound. That's where I cut it off. So if I know where I start, that's, yeah. Huh? I don't. I'm sorry.
What do you want to do?
Oh my gosh. All right, so I'm gonna do the same thing for the next one. Start at 2, and I'm gonna plug it in. Well, if you plug in 2, 2 over 2 is 1, and 1 plus 1 is 2. So I got 2, 2, again with an open dot. So I have a hole in my graph here, right? This function is not defined at x equals 2, and I'm gonna guess that that's gonna come into play somewhere with these limits, somewhere in this question. That's gonna be asked of us. I'm going to plug in 3 because it says x needs to be bigger than 2. So if I plug, I'm going to plug in 4. I'm going to plug in 4 and get out of my fraction there. 4 over 2 is 2, and 2 plus 1 is 3. All right, so my first question asked me to graph it, done. The second question asked me to determine the limit as x approaches c from the right and as it approaches c from the left. I'm going to guess c is 2. C is 2. It gave it to you in the problem. What is the limit as x approaches c from the left of my graph? Does it matter that it's an open dot there? No, it does not matter. It doesn't have to be defined there. Okay. How about as you approach from the right? And then part C, I'm not going to write this. We'll talk about it. Does the limit as x approaches C exist? Why? They are different. Are y'all seeing the important part of this section here?
So how do you want us to answer it on a homework graph?
Well, part A said graph it. Part B said determine the limit as it approaches C from the right and then as it approaches C from the left. So this is part A, this is part B. Part C would be no because the one-sided limits are not the same. Right. Yes. What? It should not, no, because you're cut off one. What's the graph of 1 over x minus 1 look like?
Well, this is what the graph look like. That's what my calculator showed.
Okay, so you cut it off. This is 1 over x minus.
Was I looking at the wrong question?
Well, no. Sorry.
Way to read it like 100 times.
Man, what are you talking about?
We have to read.
All right, so it cuts it off at 1.
Yeah.
Yes, it is approaching infinity.
Okay, so wait, well, yours is going the whole other way. No.
Well, it says less than 1, so it approaches negative infinity there. So it's going to have this bottom corner.
Okay, so that's what mine look like.
Yes.
And but the top has a limit though. The top one
It
is
does.
4.
It does.
4.
It does. Right.
Yes.
All right, quickly, because I don't want to run out of time. I want to get through to answer all these questions for you. Yeah, same way. Same way. Okay, for that one, if you look at it on your calculator, there's an asymptote here, and it looks like that. And it's not included on that one, so that's why it goes down forever. All right, 61 and 63, those are the exact same thing. The only difference is your trig functions there instead of algebraic functions. Yay! So I'll come back to that if we need to, if we have time at the end. Let me look at, okay, I need to show you Sandwich Theorem real quick so that you can do 67 and 69, yes. Yes, put this in your notes quickly. It's an easy concept, but it's the very last thing with limits. I'm probably going to add, oh, you have 65 and 67, so that'll be 2 Sandwich Theorem ones, so that's good. Okay. Tomorrow, this is tonight. I'm not going to add anything to it tonight. Let's fix what you did last night because some of you were so overwhelmed. I had planned to let y'all to answer questions and then let y'all work in groups on finishing it up, but we won't have much time to. So, do you feel like your brain is just? Yeah, I understand. Listen, when I tell y'all, I know that y'all are used to teachers like dinging you and writing you hard about, and I want you to take it seriously, and I want you to work hard, and I want you to try. But like I told you last night, all I can ask is that you try. If you are to that point where you are so frustrated you cannot even see straight, you are no longer trying, and it is not productive for anybody. I definitely don't want you to do everything wrong and me have to unteach you and reteach you because then we're taking 3 times as long to do it. Okay? Do what you can, do the best you can. That's all I can ever ask as long as you're trying. You know what is trying for you, and you know what is not trying. Y'all did not get to this point in life not to know what is trying and what is not. Okay? Now I say that, but don't just quit trying altogether because, well, Miss McGee's so lax with us. This puts a lot of responsibility on you.
I just never started trying last year, so I'm really having to try a lot.
But that's okay because right now we're relying on a lot of pre-cal and we're relying on a lot of that. But as we get more, I've given you everything that you need to know cold. It's gonna I've thrown a lot at you. It won't disappear. Well, except for yes, you will. It doesn't work like that. Okay. 3 functions. I've got 8. It isn't at 9:50 or 9:55. Oh, is it 55? Okay. So I've got almost 15 minutes. Okay. Sandwich theorem. Let's imagine you have 3 functions. And when you graph them, and this is just an introduction to sandwich theorem. We will do a lot more with it as we get further in. Right now, I just want you to kind of understand what it is it's doing. One is, okay, so 3 functions. When you graphed, one is sandwiched between the other 2. If the limit of the 2 outside functions, and I'm going to show you an example, show you exactly what it looks like whenever you graph it so you know you're in sandwich theorem territory. If the limit of the 2 outside are the same, guess what? You got 3 functions. If the 2 outside are the same, and the middle sits in between the other 2, then the middle is the same too. I'm gonna show you what it looks like. Yeah. If you've got a function on top and a function on the bottom and then something in the middle, if the limit of the top one and the limit of the bottom one are the same, then the limit of the middle one has to be the same also. Okay. All right, let me show you what it looks like. Here's what it looks like, first of all, not in words. If this is true, and I'm just going to put a value here. If those 2 things equal some arbitrary value, then the middle one does also. Are they? I mean, they're not bad, but Kinsey is a studier, though. She is very much a. Kinsey's my one that tries really hard. Parker's my one that couldn't give a flip, but is smart. He's the one that frustrates me the most. Just any arbitrary value. X. All right, let me show you graphically what it looks like and do an example, and I'll be done. Hopefully I can get through it. I don't want to rush. That's fine. If you want to come back, yeah, that's fine. The notes are always there for you, too. Why do you keep saying this? So, if you look at this one, and most of these will be based around something like this. In fact, this is really close to number 67 on your homework. If I look at this one and I say, okay, I know what? Yeah, if it's not, yeah. You need to look, make sure, remember if it's shaded in gray, that means it's non-calculator. If you were to graph x squared sine 1 over x, you would get this funky looking graph that looks something like this.
Like the one that, the 67 gets like really tight.
Yes. And as the more you zoom in, the more this starts. Okay. This is actually sandwiched between x squared mine's a horrible drawing. If you did it on your your calculator, you would see a little better. It actually kind of does this number where it, okay, but it hugs, it's sandwiched in between. It hugs both x squared and negative x squared. Okay. So, yes, yes. So it's sandwiched. No, just draw one, just so you know that it's. Okay, so here's where I think about this. Do you agree that the sine of 1x, I don't want to get in too deep with this, the sine of 1x will always lie between negative 1 and 1? Agree or disagree? It's always the y value of the sine of 1 over x, even though I'm flipping it over, the sine of pi over 3 is 3 over pi. I mean, it's always going to lie between negative 1 and 1. So if I took this and then I said, okay, well, I'm going to multiply all sides by x squared, would you then agree that I do this property with an inequality is what I'm asking you? I can multiply all sides by whatever I want, right? That leads me here. Okay, so you got graphically and algebraically there. So what I'm going to ask you, because look what I was initially asked. What's the limit as x approaches 0 of this nasty function? Well, what's the limit as x approaches 0 of negative x squared? What's the limit as x approaches 0 of positive x squared? Therefore, by the sandwich theorem, this limit equals 0 also. Okay? Because it sits between them. Okay? Here's the way you're always going to use sandwich theorem. You're going to put your basic trig function in the middle. If it's sine or cosine, it's between negative 1 and 1 every time. And then whatever you need to do to the middle to make it look like this, you just do it to all sides. Okay? And then you can find the limits of the outsides, and it'll tell you the limit of the inside. Both defined at 0. At x squared, if you've just got a parabola, what's the limit as you approach 0? Right? As I come from the left and as I come from the right, it's still 0. Same thing if my parabola is upside down like this. Still 0. Oh, yes. Sorry. Yes, they do. They do. But it still oscillates between them, and it comes through right here also. And yeah, sorry. Right. The graphical part is hard for me. I understand the algebraic part of it. The algebraic part meaning take that trig function, put it in the middle, and then adjust the ends. Okay, but 9 times out of 10, this is your starting out, and then you're going to do whatever you need to do. So 65, let me just show you quickly how to set it up algebraically, and then you should be good to go. 65 asks you for the limit as x approaches 0 of x sine x. Okay, I don't know x sine, but it asks you to use the sandwich theorem to confirm your answer. So what I'm going to do, I'm going to put that sine x in between 1 and -1, and then multiply by x, multiply by x, multiply by x. Yeah, so then you'd have -x. So if limit as I go to 0 for this one is the same as this one, and it is because it's 0, then it's got to be 0 here also. It's not always 0. These are just going to 0. All right, and you should be able to do 67. Yeah. I did that one for you and I didn't mean to. You don't have to. I was just showing you how it, just because that one was like this and then the other one, then they should touch.
Let's finish up this stuff.